In this demonstration, we're going to see how we can use QAC++ to analyze some code from Rhapsody and to distinguish between the handwritten code and the machine-generated code, so that the developer using the tool can spend most of his effort on attacking the issues in the code he's written, rather than worrying about the issues in the machine-generated code. Now, to do that, we're going to create a project in QAC++. So we're going to select New Project, and we're going to browse to where we're going to put the project. I've already got my Rhapsody project here, so I'm going to make the project there. And for the analysis configuration file, I'm going to use the Rhapsody configuration, which we'll have a look at shortly. And for my rule configuration, I've got a pre-configured project configuration here, and the rule configuration just tells QAC++ which messages are turned on, which messages are turned off. The only other thing I need to do is to tell QAC++ what compiler I'm using. So I'll filter the list, and I'm using Microsoft Visual Studio 2008, and I've only got C++ files in this project, so I only need to choose a configuration for C++. So we'll create the project, and then we'll just have a quick look at some of the configuration in the project. For the analysis, for the C++ code, we're taking advantage of a new feature called code regex, which allows us to convert code in the source files into other code. In this particular case, we're converting the comments that Rhapsody uses to demarcate handwritten code and machine-written code, to convert them into comment-based suppressions that QAC++ can understand. Thus we can filter out the messages and suppress the messages from the machine-written code. I'm also going to turn the data flow analysis on as well. I think we can do that at depth 1. There are a number of different depths for data flow, and depth 1 is the fastest but shallowest data flow. So I'll save that configuration. And then the next task is to actually get our project into QAC++. And the easiest way to do that is to synchronize it with the build process. There are a number of different ways we could do that. If we build our project using a batch file, I could call the batch file, but the easiest way is I'm just going to run the Rhapsody GUI and build the project within Rhapsody. So I'm going to use the synchronize option, and for my build command I'm just going to choose Rhapsody, and I'm going to synchronize, and I get the option to run the analysis at the same time. I'm going to say no for the moment so we can run the analysis once we've synchronized. So now QAC++ is starting Rhapsody, and all I need to do is to open my project in Rhapsody, generate the source code and build it. So we'll open our project. Everything I'm doing now in the GUI can be repeated on the command line. You can automate most GUIs to do generate the code. So I'm just going to generate my code there. And all the operations we've done in QAC++ can be automated from the command line. So we can reproduce this analysis in something like a continuous integration system. So that's my code generated. I'm now going to build my project. So we can see down here the files are being compiled, and if we switch back to QAC++, we can see the files being synchronized with our project in QAC++. As we synchronize the project, we extract some information from the compile command lines, like the defines that are used and the include paths for the source files, and I'll show you those in a minute. And these are needed for the analysis phase, because we need to know what defines the file was compiled with and where the include files are. Okay, so that's the project built. We can now leave Rhapsody and go back to QAC++. It's just finalizing the import, and we can close the synchronization window. So we can see the files have been pulled into the QAC++ project, and if we open a file, we can have a look at the include paths that have been obtained from the compile line and the defines as well. We didn't analyze the code as we were importing it, but we could choose to do that. But we're going to analyze the code now. Analysis takes a couple of minutes, but we speeded it up here in this presentation. So the analysis is finished, and we can see that all the files have been analysed successfully. So we've really had to do very little setup to get our project working and analysing in QAC++. So let's go and have a look at some of the files. So we can see that we have two totals columns here. A total, which gives us the absolute number of messages and instances of messages in the files, and then the active column, which tells us how many messages are unsuppressed. And these unsuppressed ones are the ones that are in the handwritten code. These are the ones we want our developers to go in and fix. So we can see that this file here, car.cpp, has got 26 issues in it. So there's several different ways we can look at the issues. We can scroll down, or we can look at the rule groups. So we can go down to, say, design problems, which is the key area. We can see that there's some unset data. So let's have a look at that. And we can just show that message only. And if we double click on that, we can go to that issue. So here we can see we have a variable that's a local variable that's been used potentially uninitialized. So it's an apparent message, which means there's a path through this function where this variable could be uninitialized. So if we look up, we can see that it's created here but not initialized, and then there's a loop here where it may be initialized depending on the outcome of this if statement. So we could potentially get to this line here and tn would not be initialized, and using the value of an uninitialized object is undefined behavior. So that's quite a serious bug, so the developer needs to fix that either by initializing the variable, or perhaps better, catching the variable not being set after the for loop and taking some appropriate action. So we can also have a look at the other messages in the other files. We can see that many of the files have only a few or no issues in them, and the header files are completely free of hand-coded issues because they just contain all machine-generated code. So we've shown that we can use QAC++ to easily extract information from Rhapsody and create a project, and we can analyze that code and differentiate between the handwritten code and the machine-generated code so that we can easily focus in on the issues that the developers should fix rather than having to fight their way through all the machine-generated code results.